We are going to describe or use attributes to describe 2D and 3D shapes. Actually, we're not going to do 2D shapes. We're going to do 3D shapes. Our teach for today, what you're going to be doing in your stations is you're going to be using attributes to describe 3D shapes. Now, we've been doing 2D shapes. Can somebody tell me what do you think the difference is between a 2D and a 3D shape? This is my 3D shape. We've been working on 2D shapes. What do you think the difference is between a 2D and a 3D? Now, this is what we're getting ready to do, but we know a lot of information about 2D shapes. Francis, what do you know about 2D shapes and 3D?
3D has vertices.
Okay, so when we're going to be looking at 3Ds, we're going to be looking for vertices. Can you tell us what a vertice is?
It's like little points.
Okay.
Edges.
It's a big word for what now? We no longer say this anymore. We call it a vertex or vertices. Riley?
It's a word for a corner.
It is a word for corners. Can you tell me, what do you think creates a vertex or a vertice? What makes it a vertex or vertices? Kevin?
It's when two of the walls get together.
Very good. Okay, it's where the walls get together. Can somebody help them out with another definition? What do you think, Brendan?
2 lines meet.
Okay, what are those 2 lines? When you have this line and this line meets, these are lines. What do you call those lines? That's another vocabulary word that we want to work on. James?
Edges?
Very good. So would you use edges for a 2D shape? No.
Because you can't feel it.
Can you, what was that, Kevin?
Because you can't feel it.
Well, if you have a 2D shape, but why don't we call it an edge? Can somebody tell me what makes an edge? Why do we have edges on a 3D shape? Yes?
It's like when the sides are coming together, it makes an edge.
Okay, but there's a word I'm looking for. We don't say sides on a 3D shape. We want to use what vocabulary word?
Edge.
What? Not parallel. What do we call? He said sides, but we don't call these sides. We want to call them?
Faces.
Okay, faces. That's another vocabulary word we want to focus on today. Vertices, edges, faces. But let's go back and talk about 2D shapes. Do you think that on a 2D shape we're going to have edges?
No.
What are we going to call them?
Angles.
Okay, well, we have angles. We did talk about angles with 2D shapes. Do you remember what angles we talked about on a 2D shape? Yes.
A 2D shape has no faces or just has one face.
It has one face. It only has what's the word? It doesn't have. Let's see. It has sides. Or it has a side. It doesn't have. You're right. It doesn't have. It has a 2D face, right? A shape. It has a shape on it.
It has one, but 3D shape has faces all around it.
Thank you. Very good. Yes.
For the 2D shapes, like it's almost like a sphere because like it's almost the shape of a ball and it doesn't have no faces.
So it has a shape. It has a 2D shape. A 3D, you can see all the way. Do you remember what we talked about? What's a big difference between 2D and 3D? There's a big difference. We talked about it. Let's see. Paul, what do you remember?
One has right angles and one doesn't.
Okay, well, these have right angles, but 2Ds can have right angles, but also some 2Ds don't have to have right angles. They can have different angles, like acute angles, or what was the other one? Obtuse angles. Yes, Kaden.
The 3D has
Who remembers? This is a big. That's why we're studying 3Ds. We're something totally different, going from 2D to 3D. If I need to pull out my poster, what do you think, Taylor?
on a 2D shape, you can't see all the way around, but on 3D you can.
Very good. She's correct. On the 2D shape, you cannot see all the way around, but on a 3D, you can. Can somebody use different vocabulary words? What? She's right. On a 2D, why do we only see the front of a shape?
Because on 3D is the length, like how tall it is, how
Wide it is.
So
how
you
wide
have
it is, and
you have have length
And the width.
times width.
times
Length.
What is it?
Height.
Height. Hold on, Mia. I'll get to your.
and 2D has length times height.
Well, length times width. Okay. So remember, now we have another dimension. We can actually see all around this shape. Because of this, you had length times width. Now that you have a 3D, you got how high it is, you have how long it is, and now how wide it is going towards the back, right? That's why it's called a 3D shape. Yes?
A 3D shape you can roll or slide.
Very good. A 3D shape you can definitely roll and slide. What about a 2D?
It will.
No.
Don't do it. Just like.
It's just a flat surface. Yes.
That 3D has 3D like 3D is hard to draw, but 2D is just
Yeah, it is.
Simple.
Yeah, the simpler one. You're right. That's a good one.
Yeah,
The 3Ds are pretty easy. Now, I know that we've been working with shapes for the last couple of days, but we're going to review some of these shapes. First of all, raise your hand and tell me, what is this shape? Yes, a cube. Okay, it is a cube. What kind of faces does this cube have? You're looking at it, what kind of face?
Square.
It is a square. On a cube, you can count the number of
Faces.
or
Edges.
edges. And all faces are, like he said, squares. Now, yes.
And on a 2D you only can count the right angles.
On a 2D, you can count the angles because they can be right of choose. But there was one important one that I wanted to hear and I haven't heard it yet. What did we study about 2D shapes that I did not write up here? What do we know about 2D shapes? What do we know about some? Raise your hand. Mia?
They all have four sides.
Well, what kind are those then? Quadrilaterals. Raise your hand.
They all have parallel lines.
Oh, not all, but some can have one pair, or they could have two pairs of pairs. That was what I wanted to hear.
What about
Parallel
a 3D?
lines. What?
Well, a 3D could have like a parallel line.
A 3D can have a parallel line. This could be parallel to this. But if you're doing that, look, you're comparing this line and this line. It's almost like looking back at a 2D. So do you see why when we're looking at parallel lines, we're doing 2D shapes? So I'm going to move on from the cube. We're all familiar with the cube. The next one that I want to show you. Cylinder. This is a cylinder. Can the cylinder slide?
Yes.
Can it roll?
Yes.
Okay, yes.
It has a circular base.
It has a circular base. Now what we're doing is we're describing the attributes. Do you remember what attributes mean?
I know, like, if you made one of the, I forgot what they were called, but like how you have them different than how like they're like.
Like a Venn diagram?
Yeah. That one, if you would compare like another shape with it, that would be like right in the middle because it only has two faces and the other side it has a curve.
You know what? Speaking of that, there's a misconception. Give me a second, Taylor. When you do this today, a lot of third graders get confused with this. They're going to ask you, how many curved surfaces does this shape have? There's a lot of misunderstandings about that question. How many curved surfaces does this shape have? Kevin?
One.
It has one. Some students want to go, well, it's curved here. Here's another one. Here's another one, but it's still one curved surface. And I like the way Abdul said this is a circular base. And how many circular bases or surfaces do we have? Two. That means that I can actually stack them if I wanted to, right? All right, so now we have a shape that you cannot stack. It actually rolls. Raise your hand. What do you think, Dana? It is a what?
A sphere.
A sphere. Very good. It is a sphere. It is a?
Ball.
It looks like a ball. It rolls. I have a question. Yes, LG.
A sphere has no faces, no vertices, or no edges.
But it has?
Curves?
It curves. I hear that plural. One curved surface. Very good. So this is your very easy one that we all know. Now I'm getting ready to move on to one that's a little bit harder to remember.
Triangular prism.
Thank you. What makes it a prism? How do you know it's not a pyramid? Those are the two that students get mixed up with. What do you think, Hayden?
Pyramid has 4 rounds.
Okay, a pyramid is not round, but it goes up more like
It's like
It stands up straight.
faces. It has more faces. Okay, a pyramid does have more faces. We've learned about 2 types of pyramids. Okay, what else were you going to say, LG?
It stretched like a rectangle.
It does look like
And
it's...
then the faces are triangular.
Are they only triangle faces?
No.
No. What do you notice about it, Taylor?
The pyramid, it goes, it's not as long, but the triangular prism is long.
Very good. Mia?
For the triangular prism, it doesn't have, like, on the side of the triangular prism, it doesn't have a rectangle like that side does.
Very good. You're right. Abdul?
Because a pyramid actually goes like all the way to the top from like the edges, goes like this, but that just goes, I don't know, like it goes just,
It's not as high.
yeah.
It doesn't have it. Okay, we're moving on. What do you think about this one? Mia? What do you think this shape is? Is it a 2D shape? Just a rectangle, but you're halfway right. Help her out, Danielle. It is a rectangular prism. Look how long it is. Remember I said imagine you can look through it. It's a prism. What is this rectangular prism made of? What kind of shapes are they made of, Jalen?
Squares and rectangles.
Squares and rectangles. Are they always made of squares and rectangles?
No.
No, you can have all your faces the
Same.
same. What were you going to say, Francis?
You don't always use them because you can use like a triangle and a rectangle to make like rectangular, like triangular prism.
Okay, yes, you're right, like this one that we just did. They changed it. Okay, and Mia, a cone. Well, can you tell me about a cone, Francis?
It has one apex and one curved
Surface.
surface and just like one.
Looking for that vocabulary. I'm looking for those vocabulary words. What?
One face.
What kind of face?
Circular base.
Circular base. It's got a circular face. It's a base. Yes.
A cylinder or cone. A cone. It can only roll. It can't roll forward.
It actually just rolls what?
It rolls around because of the face. It gets the face is bigger, so it keeps its balance and it keeps it rolling around.
Very good. Now, what you just did, if you would put your hands down for a second, I'm going to explain what we're getting ready to do. What you just did was, can somebody tell me what y'all just did as a class? What did you do, Abdul?
We just
Describe
describe attributes.
of?
The 2D and 3D.
Well, we went and talked about 2Ds, but today we are doing 3D. Now, this is yours. I'm going to give you a little group assignment. But you wait. I'm going to wait for the assignment. I'm going to put you, actually, I'm going to put these two in groups. You're already a group, and you're a group. I'm going to give you a poster. You're going to get one baggie of shapes, and as a group, you are going to fill this out. Now, some of y'all are going to be able to quickly know the answers, but you're going to have the shapes right there in front of you so that in case you're not sure, you can take it out and count them. It says number of faces, number of vertices, number of edges. The last one says shape of faces, like the cube. What are the faces?
Square.
Squares. Now, As a group, you're going to fill it out. Cube, triangular pyramid, square pyramid, rectangular prism, cylinder, sphere, and cone. As a group, you're going to fill it out. Then we're going to stop. I'm going to give you only a few minutes to do this. And then we're going to check our work before we move on to our stations. So, let's have Cadence group. Yes, go quickly.
Just read the cube and then you'll see a number of faces and then we'll all figure it out together and you'll write it.
Here you go.
Do I do a whole line or do I do you do a whole line? Yes. 7. You do the whole line. If there's 5 of them. And then 12. What shares? Yeah, so basically you'll just read, but everyone gets to at least write it. So you'll read the first line, you figure it out, and you write it, okay? And then you'll go the whole line, and then you'll go, and then
We're always 7.
Ready?
yeah.
Okay.
Okay. She's gonna read that one, and then we're all gonna figure out. She's gonna write.
So remember, you can't see what?
Like it's upside down.
Oh,
Me too.
it's kind of hard, but make sure that you turn it around. Yes.
That's why she's
Or we
reading
can put
it.
it here and flip it.
Well, that's why she's reading it, basically. No.
Remember that when you have a picture, if it's a little confusing, and some of y'all start to count over again the faces. Watch this. Watch. You ready? I'm gonna help them count the faces because I know sometimes you start doing this and then you lose count. Sometimes. So here it is. Always start with the top. 1. If you have a top, then you have 8. So how many do you have right now? Now remember when I talked to you about this, when you're looking at this shape, how many edges do you have? How many edges do you have? Now if you have an edge here, what do you think is going to come off this edge? What's going to come off this edge? I told you about that before. Here? Here? So how many faces came off this shape? No, just on 4. Plus the one that you said on top and the bottom. What does it give you? 6 faces. Again, I'm going to show you something now. How many vertices do you have right here?
4.
Okay, if you have 4 on top, what does that mean you have at the bottom? Another. So how many total? Now remember, I told you that when you are working with your shapes, it can be very tricky. You cannot quickly just start counting, or if you have a picture of it, what is the strategy that I want you to do? If you have a picture, what do? You can put a little dot, right, so that you don't recount it again. Okay? So let's go ahead. How many vertices do we have? Right here. And then the bottom. Okay. Do you see it, Danielle? Again, how many do you have here? How many going down? And then on the bottom.
No, it couldn't be triangle.
Let me check.
Because look right here.
What's this right here?
This space right here on the side.
Okay, ready? Let's count. You don't have it. For some reason, I don't know where it went. But you ready? Let's count our square pyramid. What are we going to count? Faces. So you had 1. Hold on. So very good. So he has the 5 faces. Did you see what he did? 1 face, and he goes, oh, there's 4 edges. There's a face here. There's a face here. There's a face here. There's a face here. He's right. There's 5. Let's do the number of vertices. Okay, how many vertices do we have? 4. Just looking at it right now. How many? Because what are vertices? They're the corners created by the edges. So how many vertices do you have here? And then, okay, what do we have? Okay. Can you do me a favor? Will you please recount your edges for me? Wait, let him write down, and then together. You can think about them, and we can share our ideas out loud. But right now, I want you to help me fill my chart up. I want to see if we all have the same answers.
No, put it like this so we can all see it.
Now I walked around and I heard lots of good examples from your questions that I have on the back. I know there was 2 groups that didn't get to it, and we're going to talk about those questions because I think they're very important. It's the reason why we have to know 3D shapes and 2D shapes. It's important. So, can somebody, I'm going to go with James's group. Can you tell me, what do you know about the faces on a cube? Danielle? Do y'all agree with Danielle?
Yes.
James, how many vertices did your cube have?
8.
Wait. 6.
What?
Vertices.
The number of faces.
Oh, sorry.
faces
I'm
is
so sorry. 6. The number of vertices.
8.
Francis, the number of edges.
12.
Do y'all agree with him?
Yes.
Now, Paul, what were the shape of the faces on your cube? Do y'all agree?
Yes.
So far, your posters look okay?
Yes.
Because we want to make sure we have our answers correct, because I'm going to use these around the classroom as a reference for your stations.
You don't want to have the wrong answer.
Exactly. Triangular pyramid. This was a little tricky. The triangular pyramid was difficult, but I've taught it to you before. So LG, the number of faces.
5.
Okay, so here's my triangular pyramid. I'm going to look at the bottom. How many edges do I have?
6.
No. Right here, babe. How many edges do I have right here?
3.
So if I have 3 edges, what's going to come up off those edges? 1 face, 2 face, 3, and the one on the bottom?
3 faces. 6.
How many faces? How many faces?
4.
4. Again, here is my triangular pyramid. Okay? Here is my triangular pyramid. Again, what is it? What's on the bottom? What shape? A triangle. So if I have a triangle on the bottom, that means how many faces are going to come up? 3. Plus the one on the bottom makes it 4. This one was a tricky one. Okay. Dana, how many vertices do I have?
6.
Let's count. It's okay. You might have had a different shape in there. Let me see what you have. Actually, I don't think I even gave it to you. This is your triangular pyramid. Again, how many vertices? Looking at it.
6.
No, looking at it. Vertices. 1, 2, 3. And the one on the top?
4.
Okay, how many vertices, class? 4. Now, there's a difference with that one and this one. What do you have on the bottom of this one?
Square.
A square. So that's where some of y'all might have gotten confused. This has, we briefly talked about it. This has a base of a triangle. It's okay. That's why we're doing this. So here is my triangular pyramid. How many edges do I have here?
3.
1, 2, 3. How many, so if I have 3 edges here, how many edges are coming up? 1, 2, 3. How many edges all together?
6.
Now, and I think it was Kevin. Kevin, what he saw a mistake really at the very end. He said, hey, that says triangular pyramid. I heard him. And he says, if it's a triangular pyramid, right away he went and changed it. What kind of faces does it have? Only what? And he caught that. He fixed his. This was a tough one. After the triangular pyramid, yes ma'am. It's okay, but did you see it now? Do you understand it now? That's why we're doing this together. The next one is my square pyramid. So, how many faces are on the bottom? How many faces do you see? 1. Okay, but I have 4 edges, and you already know that if I have an edge, what's coming up? A face. So if I have 4 edges, how many faces are coming up? 4 plus the one on the bottom?
5.
So we have 5 faces. Vertices. You ready? Abdul. How many on the bottom? 4 and 1 at the top makes 5. Again, I know there's some students that still are not sure about a vertex is one, vertices is more than one corner. We don't say corners anymore, we say
Vertices.
okay, the number of edges. You're looking at this, count your edges at the bottom. What shape is this?
Square.
How many edges do you have on a square?
4.
So if you have 4, how many are going to come up?
4.
And altogether you have?
8.
8.
Oh, we did pretty good.
And? Yes, Kevin?
I thought you didn't count the top one.
Only on a cone. Because what makes a vertex? Can somebody repeat the definition of a vertex? No. Faces do help, but what meets? What? Okay, when you have 2 edges, 2 or more edges will make a vertex. So do you see this edge? Do you see this edge? This edge, and what are they making? A vertex.
I meant on vertices. I thought you don't count the top one.
Yes, you do. Because it's being created by edges. Only on what shape, class? The cone. Can you tell me, Brooke, what shapes of faces do you have on this? What are your faces? Very good. Square and triangle. Okay, now we have our rectangular prism. Hold on, James. We're going to finish this. Rectangular prism. Can somebody tell me how many faces do we have? Yes. 6 faces. Do y'all agree? Number of vertices. Do y'all agree? Melissa, how many edges did you have on your rectangular prism? Brooke, what did y'all have for your rectangular prism? Do y'all agree?
Yes.
And can somebody tell me, raise your hand and tell me, what faces did you see on that rectangular prism? Brendan? Square and rectangles. Do y'all agree with Brendan?
Yes.
Yes or no? Y'all sound unsure. What do y'all think?
Yes.
Yes? Okay, Kaden, a cylinder. How many faces?
2.
Vertices. What do y'all think, Jason? Vertices for a cylinder.
C.
How many vertices on a cylinder?
0.
0. Paul, how many edges on a cylinder? Very good. And Paul, what kind of faces do you have on a cylinder? A circular face. A circle or circular face, I like that. Sphere. Abdul, how many faces?
1. So this is
It has what kind of face? What kind of surface does it have?
curve.
Curved. So if it would have said curved faces, definitely 1. But this one only has number of faces, so we're going to look for flat surfaces or faces. It's okay, because you know what, Abdul? There's another chart that you might see later that one of your options is how many circular, and I do have it. That's going to be with the teacher later. How many circular faces does it have? That's when you would say 1. But for now, how many faces, class? 0. How many vertices?
0.
Pierce, how many edges?
0.
And Pierce, what are your shapes? What is your face? The shape of faces on a sphere? Round, which we could call a circle. Cone.
So do we change it?
You can change it, yes.
I just put an X in the one that I got wrong and read the red
That's
one.
perfect. Okay, James, cone, how many faces?
1.
Vertices.
1
James?
apex.
Okay, we can call that an apex. Okay, well, how many, oh, right here, sorry. 1 apex, but no vertices. How many edges?
0.
And LG, what is the shape of faces?
Circle.
Very good. Now, because of time, I want to hear, Francis, can you turn your poster over and read your question to the class? Some of us didn't get to it. It's okay, Brendan. In a few minutes we'll read it. But this is how or why 3D shapes are important for us to know. Read your question.
Can you think of a video game or computer game where they involve shapes?
Okay, and what did your group come up with?
Minecraft, TTM, and Cool Man.
Very good. And do you think those games would have been interesting still if they didn't use shapes? Like Minecraft, do you think it would have been a great game with no shapes?
No.
No. I'm not familiar with Minecraft, but is that the one where they have little
Pixels.
they have what?
They're
You make
pixels.
like, if you have the blocks.
Wait.
Everything's a square.
Everything's a square.
cube.
Okay, I've seen
Everything's
his.
cube.
It's actually a sandbox game where you just build, mine, and obtain and do whatever
You
you
craft and
Okay, stop. No, you can show me later because I believe I've seen his books that he reads.
Yeah, you can
Now,
find animals
I know
and
this
creatures.
one.
What else did y'all say? Cool math and TTM. Okay, read your question. Wait.
Think about sports. How do 3D shapes help out in the world of sports?
Okay, so what did y'all come up with, Daniel? A what?
A spear can be a baseball.
Okay, and what else did you come up with, LG?
A cone could be a goal for basketball.
Okay, and Riley?
A cylinder could be a hockey puck.
Okay, now I have a question for you, Taylor, because we talked about it. Hold on for a second. Taylor, we talked about why these shapes were important to the game. Can you give me the example? You said why they use a sphere for a basketball and why not a cylinder-shaped ball for basketball. Can you explain why?
Because in basketball, the ball has to be able to bounce and to be able to throw it high.
Okay, and do you don't think a cylinder would be able to bounce?
No.
Okay.
And it's
All right, next question. We're going to move on. There are two other questions that we didn't get to, but they can answer it together. This is a hard one. How can knowing the difference between a rectangular prism and a triangular prism be helpful when using a computer? How can knowing the difference between a triangular and a rectangular prism be helpful when you're using this computer? Now, I'm going to tell you that my daughter came up with that question last night. I'm like, I even said, I don't know. And she was frustrated. She says, Mom, how do you not know? I have messed up so many something because I don't pay attention to the shape.
Like when you're on TTM, when you're trying to like airplanes, they actually asking you about shapes.
Okay. Okay, I'm going to share one because I know this one. I didn't know. How about the wires, the USB wires? When you're having to plug in certain games, or I have to hook my video camera when I want to watch my videos on my TV. What do you know about those USB wires?
It's like a square.
It's like
They usually have a little
raise your
square at the
hand.
end. It's just one face.
Very good. It's in a rectangular. You know, I have messed up 2 wires in my life because I wasn't paying attention, and I'm trying to shove a certain USB into the little plug over here, and I end up messing up my phone charger because I'm not paying attention, and I didn't pay attention to the little connection, the shape. And in my house, probably like your house, your parents probably have a drawer where they have tons of wires for DVD players, VCRs.
And my mom has like 2 drawers just filled with completely wires for chargers and connectors to just everything.
And I see my daughter and I have sat down for our camera because we want to charge it, and we have to go through all the wires. And sometimes if I just look at it, it's obvious to my eye that it wouldn't fit. Of course, there I am still trying to fit it in. Okay, wait. One more question. I'll get to you in a minute. Read it, Mia.
What 3D shapes do you see in the classroom?
Okay, what 3D shape do you have here in the
A
classroom?
bunch of them.
Just give me 2. The globe. And
Sphere.
the football?
3D or 2D?
3D.
On that.
my shelf. What kind of shape is this?
Rectangular prism.
Rectangular prism.